Hi, everyone, and welcome to today's workshop brought to you by Analytics at Wharton. Today, we are going to be talking about mastering the art of data visualization, with a focus on how to craft the best visualizations to include when presenting your findings in a business setting. We are going to cover topics like how to select and format visualizations for clarity and to enhance the impact on your audience. My name is Jamie Samper, and I'm the Associate Director of Data Computing and Research Support here at Analytics at Wharton. My research background lies in the field of psychology, specifically in cognitive science research with a focus on quantitative methods. And I've conducted and mentored multiple research projects in industry settings over the past several years. Throughout my research journey, I've gathered a collection of techniques and tools that have proven useful when creating clear and concise but impactful visualizations. So let's jump on in. For workshops like this, I like to start out by explaining why we should care about the topic at hand. So why should we care about knowing how to create good quality data visualizations? Why are data visualizations important? To really understand the impact that a good data visualization can have, I like to draw a comparison between data and a foreign language. When we take courses in statistics and in data science, we are learning how to speak the language of data. We learn how to navigate data, interpret output, and how to read and write code to manipulate data. We learn a sort of syntax of data through things like variable types, structure of variables, and rules about when certain variables can be compared to others and when those comparisons aren't mathematically appropriate. During this process, we are essentially learning how to communicate with a language that someone without the proper education could not understand. And this is precisely why data visualizations are so important. Visualizations can be thought of as a bridge between data and outcomes, and they can serve as a vehicle to deliver messages to people regardless of their background and prior experience working with data. Visualizations can make data understandable to anyone. To demonstrate what I mean by this, let's take a look at this random data set. If we go into Center City, Philadelphia, and we pull someone off of the streets and ask them to look at this data set and to tell us what they see, they're probably not going to be able to tell us much besides that they see some letters and they see some numbers. But someone who is trained in data would be able to look at this data set and say that there are some categorical variables here. There are some variables that are either continuous or are interval. You can see that there are some trials that repeat 1 through 12. So we've got 12 trials, and all these different trials refer to the same subject. And so we're probably measuring some type of performance for each of these subjects in each of these trials. That may not seem like much information to extract from this, but it's a starting point. And by knowing this type of information and be able to see how different data sets are organized and structured, you can start to identify possible analyses that may be appropriate for this type of data. So let's take a look at a simpler data set. A person off the street of Philadelphia likely can figure out what is being shown here. There's length and width measurements for the sepal and petal of different species of irises. This is a type of spreadsheet that any person may maintain. It is simply a log of observations or measurements. However, simple maintenance of observations or measurements is often not helpful. To make use of this information, you need to be able to extract insights from it. Without the proper training in analytics, it's not simple to identify patterns in this data set. But as a trained researcher, you are able to. Let's say your friend is growing flowers and wants to track the measurements over time and provides you with a longer version of the data set we just looked at. You decide to run a very simple linear regression to see if the length of the petal grows comparatively to the width of the petal on average. You choose a linear regression because the variables are continuous and your goal is to understand the linear relationship between the two values. You can't just show these two output variables to your friend who is not trained in statistics. These coefficients aren't going to mean anything to them. So this analysis becomes pretty useless without the proper tools to interpret the values. So you tell your friend, there appears to be a linear relationship between petal length and petal width, and that for every unit increase in width, the average of the petal length will increase by 0.4158 units. Most people won't be able to take that information and know how meaningful that value is for the data they have collected. So how can you convey your message in a better way? With a visualization, of course. When your audience doesn't speak the language of data, visualizations are key tools for translation. Now we can see what the regression coefficient means for the entire data set that we have. The length of the petal is longer than the width, but as the width of the petal gets longer, so does the length. Something that you hopefully just saw is how visualizations can help put insights into context. For this reason, and many others, data visualizations are a powerful tool for storytelling. Storytelling is one of the most important parts of the analytics process, as it encourages effective communication of a problem and a solution and the work done in between. Visualizing what a problem looks like to the client is more impactful than verbally describing it, and that impact will make your client more invested in hearing the solution. When it comes to the solution, you want to make sure your audience is identifying the main takeaway message from your slide as quickly and easy as possible. Visualizations are a great tool to achieve this because the human brain processes visual patterns quicker and more effectively than it processes descriptive patterns. And this is a fact that you can use to your advantage when preparing a presentation. I'm going to put a pin in this point now because we are going to revisit how you can use other rules about cognitive processing to enhance your visualizations later on in this workshop. Being able to create clear and high impact data visualizations is important because it's a highly desired skill that recruiters look for in the job market. In the world of analytics, you will likely be asked to prepare a portfolio of previous projects you worked on, and visualizations are a great way to make sure that your work stands out among other candidates. If your visualizations have too much information or have improperly labeled data, the viewer won't be able to identify the takeaway you are trying to show, and this will reflect negatively on your ability to communicate results even when you're not speaking. Being able to clearly and concisely convey information is crucial, especially in fast-paced environments like industry research. And lastly, you should care about creating good quality data visualizations because often they are the hardest thing to do well, the easiest thing to do poorly. And the more you practice enhancing the features and impact of your visualizations, the less arduous this task becomes. When talking about data visualizations, there are three primary categories of figures we talk about. Those are tables, graphs, and maps. Most of the fine-tuning formatting that we're going to talk about later on in this workshop can be applied to all types of visualizations. But for now, we're going to focus on graphs as there's a bit more nuance that goes into proper presentation of information in graphical format. The first step to creating good data visualizations is picking the right visualization. So if you're going to be using a graph, how do you know which graph to select? A good question to ask yourself is, what type of pattern am I trying to show? What type of analysis did I run? If you're trying to compare multiple variables, then bar charts are a great option. Vertical bar charts are great for showing category comparisons that have 7 or less levels or categories. When you exceed 7, vertical bar charts get a little bit too difficult to interpret, and so opting for a horizontal bar chart might be a really great option. Horizontal bar charts are good for showing rankings or category comparisons with 7 or more categories. So think of things like election results or sales performance. Keep in mind that this kind of arbitrary rule of 7 categories or less, 7 categories or more, is just a rule of thumb, and you definitely don't have to stick to this hard rule of 7, but just keep it in mind. If you want to show the composition of a variable, then a stacked bar chart is a great option. Stacked bar charts are great for showing part-to-whole comparisons. But keep in mind that the number of elements you're trying to show should be kept low in order to use a stacked bar chart. So think of something like the number of students in each grade broken down by male or female. Pie charts can also be used to show composition. Keep in mind that they really lose their interpretability when you have 4 or more categories. So be very careful about when you use a pie chart. Make sure that you're only showing about 3 or less categories. To show changes over time, a line chart is a really great option. So think of things like change in prices or change in visits to a website. To show the distribution of a variable, histograms and box plots are really great options. I would say opt for a histogram first, just because they tend to be a little bit more digestible from a naive audience. But box plots are really great because you can show a lot of information at once. And so I personally love box plots, but definitely be careful about when you use these. If you know that your audience is not technical, definitely opt for a histogram over a box plot. If your audience is a little bit more technical or more data savvy, a box plot is awesome, just because you can show so much more information using one plot. To show the relationship between different variables, scatter plots are a great option, like the one that we just looked at before, showing the different measurements for iris petals. So if you're trying to show the correlation between two variables, opt for a scatter plot. Bubble plots are also a really great option, and they can show relationships with 3 or more dimensions, as you can alter the size of the bubbles to indicate that more cases lie within that range. So now that we covered how to select the right visualization to display your data, we can move on to how to customize your graphs and slides for clarity and impact. The key to creating a good visualization to include in a presentation is ensuring that your audience can take away the intended message with minimal to no verbal guidance. If you're unsure where to start to accomplish this, start with these elements here. Make sure your visual has context, whether that be in a slide title or a chart title. Make sure your X and Y axes are labeled and provide the appropriate units of measurement if it's not clear. Reduce the amount of data you include in the visualization by only including what is necessary to convey your intended message. Breaking up information into multiple but more digestible figures is a better way to convey a point than trying to jam in 3 insights into one figure and overloading the audience with too much data to look at once. In a business setting, your slides will be passed around to people who were not present for your presentation of the results. So your slides and visualizations should be able to speak for themselves. So to summarize, most often, less is more. Make sure that you're only showing the information that is absolutely necessary to get your audience to the main takeaway message. And make sure that everything is properly labeled. Titles, labels, and legends are essential. Now we are going to jump into a demo in R where I show you how to create a default visualization and then how to customize that visualization for both clarity and impact. For this demonstration, we're going to be using a Harry Potter dataset because I love Harry Potter, and who doesn't love Harry Potter? Our task is going to be to visualize how many characters from the films have been sorted into each Hogwarts house. We will start out by creating a very generic default bar chart with no customizations. For this figure, and then all subsequent figures, take note of what is good about the visualization and what can be improved to enhance both clarity and impact. So using very standard R code to create a bar chart, this is what we will get. It's hard to find what is good about this figure because it's way too crowded, and there's data that is in here that we're just not interested in, like characters who attended other schools of magic or who are muggles. So let's clean this up a bit. We should first get a count of how many characters are from each Hogwarts house to validate the figure that we're creating. We can see here that we should expect to see 31 characters in Gryffindor, 8 in Hufflepuff, 12 in Ravenclaw, and 20 in Slytherin. So now let's customize our code a little bit. First, we're going to start out by dropping missing values. And we're going to filter the house so that we're only seeing those sorted into Hogwarts School of Witchcraft and Wizardry houses: Gryffindor, Hufflepuff, Ravenclaw, and Slytherin. By making this very small change, we can see that this figure is just way more clear, and it gives us a better space to identify what's good about it and what can still be improved. So before we move on, pause this and just think of 1 to 2 features that make this visualization good, and then 1 to 2 things that hold back its interpretability and or its impact. What could we change? One thing to do to enhance the impact of your visualizations is to add color. Color is great, especially when the data has inherent corresponding colors, like the Hogwarts houses do. You may have noticed that when we introduced the colors, a legend was created for this figure. The legend is just telling us that red is for Gryffindor, yellow is for Hufflepuff, blue is for Ravenclaw, and green is for Slytherin. Now, you might have noticed that this legend is pretty unnecessary because each value is labeled onto the graph. The red clearly corresponds to Gryffindor, yellow clearly responds to Hufflepuff, and so on. So one thing we could do for interpretability is just remove this. It's unnecessary information that our audience is going to look at, and that's taking up processing time for them. So let's just remove it. Another thing we can do is to adjust the colors so that they're more appropriate. Anyone who knows Harry Potter knows that this red is just not a Gryffindor red. And if I was presenting this data to Warner Brothers, I would not leave the colors like this. So let's adjust them. By knowing how to work with color and how to customize figures, you're better able to serve your client and just to be more flexible in your visualization creation abilities. So I hand selected these colors to more properly reflect the colors that exist that correspond to each of these Hogwarts houses. So this is already much better. The figure looks more appealing than it originally did, and we removed unnecessary information like the legend that we talked about. But there are still things that we could do to make the viewer's job easier to interpret the figure. So pause right now and think of some other things that you can identify. In this version, we removed the background, added a chart title, and removed any redundant axes titles. These changes might seem small, but what we just did was we eliminated information that viewers will look at or read. Thus, we're freeing up more processing capacity for the relevant information that we want our viewer to focus on. In our chart title, we have here where we're looking at the count of characters sorted into each Hogwarts house. Because we're saying this is a count, we don't need that label on the y-axis. We also removed the x-axis label of house because, again, we have in our chart title that we're looking at each Hogwarts house. All of the elements are here now, but the default size and color of the axes labels isn't ideal for easy viewing. And in a presentation, the size of your labels is really important. Luckily, we can alter these. Now you can see that the values on the y-axis are bigger and they're in black, so they're easier to read. And same thing goes for the labels of the groups on the x-axis. Now, comparing this figure to where we started, it's already just so much better. But there's one more important thing we can change to make our message clear. So let's just align on what are we trying to show? We're trying to show the count of characters in each house. But we want the viewer to understand which houses are more represented by characters. An easy change that we can make to capture this takeaway is to reorder these categories. The way the figure is now, we can see that most characters are sorted into Gryffindor. But the next house with the most characters sorted into it is Slytherin. And Slytherin is on the complete opposite side of the chart. We know that when we read left to right. We want to make sure that that ordering is consistent with the message that we're trying to convey. So let's reorganize this chart. This chart is so much better. There's less information being shown. Everything is very clearly labeled. It's visually appealing to look at, and the message that we're trying to convey is very clear in the order in which we sorted the data. Awesome job. I hope that a lot of these different elements that we changed were things that you identified early on. And if they weren't, don't worry, you'll get much better at being able to identify ways that you can enhance a visualization the more times that you create good visualizations and the more times that you present your findings. Now, let's look at another example. When working in a space like customer analytics, conducting an analysis like a clustering analysis is a really common approach to cluster customers into different groups. In this next demonstration, I'm going to show you one clustering method and the different visualizations that you can create to help tell the story of why certain clusters were created. In this example, we're going to be working with a Pokemon data set, and we're going to be looking at data that reflects different skills of those Pokemon, such as health points, attack, defense, special attack, special defense, and speed. We're going to cluster our Pokemon into different groups based on these specs. Those who are trained in data know that when creating clusters, how correlated certain variables are is important. So to identify variables that are uncorrelated, you can show a correlation matrix like this one. And we can identify two variables that are uncorrelated that can be used to create different components. In this case, the lighter the color, the more uncorrelated those variables are. So we can see that defense and speed has the lightest color here and the weakest relationship or correlation. So we're going to be using these two variables to create components. To demonstrate how uncorrelated these two variables are, we can use a scatter plot, and then we can include trend lines for each variable. Now, armed with these components, we can conduct k-means clustering and visualize k clusters. You can see here that we have visualizations for 7 different clusters. Your audience can see that all k number of clusters are mostly distinct, but you, the person trained in data science, knows that one of these number of clusters is going to be most appropriate for your data. So how can you demonstrate which option is best? Along with knowledge of the data set and what makes the most sense from the business's perspective, you can also provide your mathematical reasoning using silhouette and elbow methods. Using the silhouette method, this specific package will help to identify that 3 is the optimal number of clusters. Another way you can justify your decision is by including an elbow plot. Elbow plots are pretty easy for an audience to understand because you can just show your audience where the most severe dent is in the figure. And here you can see that 3 clusters shows the most drastic change. And so we are going to proceed with 3 clusters. Now, this example was more technical than the first example, but the point was to demonstrate how you can use visualizations to guide your audience along the story to justify the decisions that you made, why you made them, in a way that makes sense to someone who is not trained in data science. So now that we talked about how to format your visualizations using code while they're being created, now we can talk about how to format your visualizations and your slides during the actual presentation of your findings. Now, if you remember earlier on in this workshop, I told you that we were going to put a pin in how to use the rules of cognition to your advantage when presenting information. And now we're coming back to that. In this example, we're looking at the same figure presented in 2 different ways. One is with low DPI, or dots per inch, and one is with a higher DPI. You can see that the figure with low DPI is much harder to read. Everything looks a little bit blurry, a little more fuzzy. And something that cognitive researchers do when they're trying to get a participant to focus more on the task at hand and to be less susceptible to processing information from their other senses is to make something harder to read. And so they have to focus a little bit more on it. And this is the complete opposite of what you want to do when you're presenting your findings. You want to free up as many processing resources of your audience as possible so that not only can they process visually what they're looking at, they can also listen to the verbal explanations that you are providing to them. One technique that you can apply when presenting your information during a presentation is to limit the amount of information you're showing your audience by only focusing on the relevant information. Let's say you're working with a client who is interested in doing an analysis of the sources of subscriber signups. Your client tells you at the beginning of the project that they think they're spending too much money on marketing through the mail. And so they want to know how many subscribers are they getting through those mail campaigns compared to internet ads. To answer this type of question, you actually don't need all of this information about referrals, email, billboard, and magazines. One technique to make your audience's job easier is to just focus on the information that they care about, and that's comparing internet ads to mail campaigns. Another technique that we talked about during the R demo is using color. If you know that your client is interested in internet ads, highlight that in a different color. But you want to make sure that if you ever refer to internet ads again in future slides, that you use the same color to denote internet ads. If it doesn't, you are making your audience's job that much more difficult to follow the story that you're trying to tell them. Another great technique for storytelling with visualizations is to direct your audience's attention to what you want them to be looking at that time. That way, they're not using up more of their processing resources looking at information that you're not referring to in that moment. You can make sure that what they're looking at matches what you are talking about in that moment. And so to direct your audience's attention, there are several different things you can do. One is to use shading. So in the figure that you're looking at on the left, you can see that internet ads and mail campaigns are in a more vibrant color, while the other groupings are shaded. And so adding this in helps the audience to know that you're talking about internet ads and mail ads. Shading is a great technique if you want to then again talk about these other groups that are shaded out, like referrals, emails, billboards, and magazines, but you're going to come back to them at a later time. You're letting the audience know that these groups do exist. They're not what we're looking at right now, but we will come back to them. Something else you can do that has that same effect is use circles, like the ones that you see in the figure on the right here. Right now, we're talking about internet ads and mail ads, and you can then move these circles to the different groups that you're going to talk about when you start talking about that information. Another thing you can do to direct your audience's attention is to use things like color and using arrows. Another addition that you should always include with a visualization is a takeaway message. A takeaway message is so impactful, especially for when people are viewing your slides at a later date, not during your presentation. They will always know what you intended for them to walk away from this slide knowing. So in this case, the takeaway message is that the most subscription signups come from internet ads. Mail ads are not in the top 4 sources of subscribers. If your client cares about the mail ads, this takeaway message addresses their concern very directly. So let's go back to the example that we started off with at the very beginning of this workshop. We're talking to your friend who is growing different types of irises and tracking their measurements. We already saw this figure that shows that as petal length increases, petal width also decreases. You went a step further and looked at this relationship among the different species of iris that your friend grows. And we can see that the linear relationship that exists between petal length and petal width is consistent across the 3 species of iris. You can also see that the smallest or shortest petal length and petal width lies within the Setosa species of iris. This slide, with the clear chart title, the animations that we used, and the very clear chart and axes labels, makes this an impactful slide that your friend is going to remember. So let's summarize everything that we've learned in today's workshop. When constructing your visualizations, remember that less data is often better. You want to make sure that you replace your variable names that are used in the dataset with descriptive names. For example, something like petal length might be abbreviated in a dataset to PL. But when you display those findings, you want to make sure that you're changing the variable name to petal length instead of PL. In the same vein, when you're working with factor variables or categorical variables, make sure that you're providing labels for the different levels. When conducting the analysis, your statistical software will treat factor variables as numbered levels, 1, 2, 3, 4. Make sure that you're providing labels for them so your visualizations are clearer. Order your data in a way that is consistent with the pattern that you're trying to show. When it comes to titles, labels, and legends, make sure that they are present, but that they're not redundant. Use color and keep color associations with certain variables and groupings consistent across figures and slides. Now, when constructing your slides, your slide title should always be the takeaway message for that slide. You can guide the audience's attention using presentation tools like arrows, circles, and shading. Always provide takeaway messages for figures. Make sure the audience can interpret the main point with minimal to no verbal guidance. If you're unsure if your visualization is as clear as it can be, ask your friend to look at your figures and to tell you what they think the main takeaway message is. If their answer isn't what you intended, think about what you can change to make your message more clear. And remember to use visualizations as a storytelling tool. And lastly, please visit the Analytics at Wharton website for more on-demand learning opportunities. We provide recordings of technical workshops like this one, online modules in various topics, and we also have links to our courses that are listed on Coursera. Thank you for tuning in, and I hope to see you in a future workshop brought to you by Analytics at Wharton.